In this video, I'm going to be working AP Pre-Cal Homework 6.3, and so we're going to be doing a lot of trig diagrams, a lot of finding sine, cosine, tangent at radian values outside the first quadrant. So we're going to start off with some problems where we're going to draw the trig diagram once, then find a bunch of trig function values all at the same angle. So I think I'll remind you our three-step process for each of these. We're going to start by finding the theta value on the circle, and kind of reasoning with pi and 2 pi, and maybe pi over 2. Reference triangle, yeah, we're going to sketch a special right triangle, always either a 30, 60, 90 or a 45, 45, 90, and then we're going to do SOHCAHTOA. All right. The only difference is today that, we have to pay attention to which quadrant we're in, and we might have something come back negative. Okay, 5 pi over 3, start there. Okay, our first job is to find the location on the circle. So 5/3, that's kind of close to 2 because 2 is 6/3. So I'll say that's close to 2 pi, 6 pi over 3, but back by pi over 3. So we go over here, this would be 2 pi, and then we'll go back clockwise by pi over 3. Okay, but pi over 3 is 60 degrees, so I'm going to go down about there. Okay. And then I will draw my reference triangle going back to the x-axis, always back to the x-axis. Okay, and then I'll have my 30, 60, 90. Okay, for my reference triangle, the hypotenuse is always 1. The short leg on the 30, 60, 90 is the half, and the long leg is root 3 over 2. Like to write down the lengths and then check and see, okay, what should be negative? Okay, we're down here in the fourth quadrant where x would be positive and y would be negative, so I'll make that negative root 3 over 2. Okay, then, it's my reference angle of 60 degrees. Not going to be able to fit that in my diagram, but sine of 5 pi over 3, okay, I'm going to do opposite over hypotenuse, that's negative root 3 over 2. Cosine, adjacent over hypotenuse, that's positive 1/2. Tangent is opposite over adjacent, so that's negative root 3 over 2 divided by a half, so that's times 2 over 1, is going to equal negative square root of 3. And then for these, we're going to, okay, cosecant is the reciprocal of sine, so I'm going to say, all right, that's negative 2 over square root 3. So that's negative 2 root 3 over 3. Secant of 5/3 is going to be positive 2 over 1. And then cotangent is negative 1 over the square root of 3. It's going to be negative root 3 over 3. All right, 5 pi over 6 is almost all the way to pi. So that's equal to 6 pi over 6 minus a pi over 6. Okay, so I would go to pi, which is over here, and then I would go back by pi over 6, which is a 30-degree angle. So not very high up. And with my 30-degree reference angle, draw the reference triangle by going back to the x-axis. And there we have a 30, 60, 90 triangle, where that's 30 degrees right there. Okay, on my reference triangle, the hypotenuse is always 1. For a 30, 60, 90, the short leg is a half, and the long leg is root 3 over 2. I'm going to check and see, okay, which of these should be negative, if any. I'm in the second quadrant where x is negative and y is positive, so the root 3 over 2 should be a negative, and the 1/2 will be positive. A sine of 5 pi over 6, opposite over hypotenuse, that's positive 1/2. That means cosecant is going to be 2 over 1. For cosine of 5 pi over 6, adjacent over hypotenuse, negative root 3 over 2. Okay, we've already flipped this once. This would be negative 2 over the square root of 3. We did that up above, right there. So there's no sense in, like really belaboring the point again. So that's for the same reason, that's going to be negative 2 root 3 over 3. And then for tangent, I'll have 1/2 divided by negative root 3 over 2. So dividing by is like multiplying by the reciprocal. So that would be negative 1 over the square root of 3, and I'll rationalize the denominator and get negative root 3 over 3. Then, that should probably be cotangent, yeah. Okay, for cotangent of 5 pi over 6, Okay, I'll take the tangent, which I got there, and flip that and get negative square root of 3. Okay, 7 pi over 4. That's almost all the way to 2 pi. Because 2 pi would be 8 pi over 4. So I'm going to say that's 8 pi over 4 minus 8 pi over 4. And so I'm going to be going backwards from 2 pi by 45 degrees. And then sometimes I draw my diagram that way. That's supposed to be a 45-degree angle. It looks like it's a little off. But I'll put a little 45 in there. Okay, hypotenuse is 1, and for a 45, 45, 90, both legs are root 2 over 2. Down here in the fourth quadrant, this is where x is positive and y is negative, so that root 2 over 2 will be negative. And I'll say, all right, sine of 7 pi over 4 opposite over hypotenuse is negative root 2 over 2. Cosine of 7 pi over 4, positive root 2 over 2. Tangent of 7 pi over 4, that's opposite over adjacent. They're the same number, but the negative of each other, so then if I divide them, I'd get negative 1. For cosecant of 7 pi over 4, we'd have negative 2 over the square root of 2, which if you've rationalized this a bunch of times recently and you just know what that's going to be, good for you. But that's going to end up being negative 2 root 2 over 2, which is negative square root of 2. Okay, that means that secant of 7 pi over 4 will be positive square root of 2. Because I just took the reciprocal of root 2 over 2. And then cotangent of 7 pi over 4 would be 1 over negative 1. That's going to be negative 1. All right. Now, we are going to find the value, and yeah, we're just going to go one at a time. So all 3 steps, I guess, is what we're saying here. So pi over 3, and we're going to find cosecant. So I'll definitely zoom in here. Okay, step 1, find the spot on the circle. Okay, I don't always draw a circle. In fact, I haven't drawn one yet. Okay, but all the same is I'm thinking about how much rotation am I going that represents pi over 3. Okay, pi over 3 is one we just got to know that's 60 degrees from theta equals 0. And so just to remind you of that, we're going to have this thing here. That's the initial ray of the angle. And then pi over 3 is a 60-degree angle. So we're going to go up there for the terminal ray. And then we'll make ourselves a reference triangle. Right, that reference triangle is a 30, 60, 90. That 60 is in there. For all of our reference triangles, the hypotenuse has length 1. For 30, 60, 90, the short leg is a half, and the long leg is root 3 divided by 2. Okay, cosecant is 1 over sine. So sine of pi over 3 equals root 3 over 2. And opposite over hypotenuse. So that means that's going to be 2 over the square root of 3. I'll rationalize the denominator. And I get 2 root 3 over 3. So cosecant pi over 3 is 2 root 3 divided by 3. Cosine of 7 pi over 6. 7 pi over 6 is a little bit bigger than pi. And so I'll draw myself a circle and say, all right, I'm going to pi plus an extra pi over 6. So that would be going to about there. Oh. And label the reference triangle. Hypotenuse is 1, short leg is a half, long leg is root 3 over 2. You check for things possibly being negative. I think both of these are going to be negative. And then cosine is adjacent over hypotenuse. That's negative root 3 over 2. Yeah. Sine of 2 pi over 3. 2 pi over 3 is almost all the way to pi, which would be over here. It's going to be back by pi over 3, so I draw the terminal ray. It's up here, up 60 degrees. And then draw my reference triangle. Okay, that'll work. And then get to labeling it. The hypotenuse is 1, the short leg is a half, and the long leg is root 3 over 2 because it's a 30, 60, 90. It would know it was a 45, 45, 90 triangle if we were working off some kind of number of pi's over 4. Okay, Now check for being negative. The 1/2 is going to be negative, and the root 3 over 2 will be positive because I'm over there where x is negative and y is positive. Okay, and now sine is opposite over hypotenuse. That's positive root 3 divided by 2. Tangent of pi over 4. That's 45-degree angle in the first quadrant. Go up like that. Draw myself a reference triangle. Give it the labels. Hypotenuse is 1. Legs are root 2 over 2 because it's a 45, 45, 90. They both are going to be positive because I'm in the first quadrant. Tangent of pi over 4 is opposite over hypotenuse, root 2 over 2. I mean, not over hypotenuse, opposite over adjacent. Root 2 over 2 divided by root 2 over 2. That's going to be positive 1. I have 11 pi over 6. 11 pi over 6 is almost all the way to 2 pi, which would be 12 pi over 6. It's just short of that by pi over 6, which is a 30-degree angle. So here, it's not a line. That'll be a line, but that's, okay, that'll do. And then I draw a reference triangle back to the x-axis. And then I get to labeling it and doing SOHCAHTOA. So hypotenuse is 1, short leg is a 1/2, long leg is root 3 over 2. Okay, x is positive, y is negative. All right, there we have it. So cosine is adjacent over hypotenuse, root 3 divided by 2. Secant 4 pi over 3. 4 pi over 3 is bigger than pi, but not all that close to 2 pi. It's closer to 1 pi. So it's pi plus pi over 3. So I'll go to pi, and then pi over 3, 60 degrees farther. Draw the terminal ray. Get a reference triangle. That'll have to do. Reach a little farther down. There we go. And it's the reference angle. Hypotenuse is 1. Long leg is root 3 over 2. And short leg is a 1/2. Okay, in the third quadrant, both x and y are negative. And secant is 1 over cosine. Okay, so cosine of 4 pi over 3. That's going to equal adjacent over hypotenuse, negative 1/2. So as a result, secant of 4 pi over 3 will be negative 2 over 1. Right, cosecant of 5 pi over 4. 5 pi over 4, a little bit bigger than 1. Bigger than 1 pi. Bigger than 1 pi by pi over 4. So I would go to pi, which is the far left edge of the circle, and then I would rotate 45 degrees more. So terminal ray will be down there. And I'll draw a reference triangle by going from the terminal ray back to the x-axis. And then this is going to be a 45, 45, 90 triangle, or at least my best effort at one. Okay, so hypotenuse is 1, root 2 over 2, and root 2 over 2. In the third quadrant, both x and y are negative. Then cosecant is 1 over sine. So I'll start with sine of 5 pi over 4. Okay, opposite over hypotenuse is negative root 2 over 2. Okay, so cosecant would be, I would flip that and I'd have negative 2 over root 2. And that would give me the square root of 2, or negative square root of 2. All right, tangent 4 pi over 3. 4 pi over 3, we've already gone there. That's bigger than pi over 3, or bigger than pi by pi over 3. It's 3 pi over 3 plus another pi over 3. So we'll go down there, and might should have just gone back to that diagram we'd already done off the same angle. Okay, but it's all right. Okay, we've got our triangle. We're going to label it hypotenuse 1. So 30, 60, 90. The longer leg is root 3 over 2, and the shorter leg is a 1/2. both negative over here, and so tangent is opposite over adjacent. Negative root 3 over 2 dividing by negative half is like multiplying by negative 2 over 1, and that's going to equal positive square root of 3. Cotangent of 5 pi over 3, 5 pi over 3, almost all the way to 2 pi. 2 pi would be 6 pi over 3, so I'm going to go back by pi over 3, back by 60 degrees from all the way around. Draw the reference triangle, label it, and do some SOHCAHTOA. 1/2 and root 3 divided by 2. X is going to be positive, y is going to be negative, so the root 3 over 2 will be negative. All right, and cotangent is, I would say I'd just do adjacent over opposite for that, but if you wanted to find tangent first and then find the reciprocal, that's totally an option you've got. But I think I'm just going to, take the x, or the horizontal leg, and divide it by the vertical leg on my reference triangle. So that's 1/2 divided by negative root 3 over 2. So times negative 2 over the square root of 3. That's negative 1 over the square root of 3. And if I was to rationalize the denominator, I would get negative root 3 divided by 3. All right, terminal ray drawn from radian measurement theta and standard position intersecting with a circle of radius r. Find the coordinates of the point of intersection between the ray and the circle. And I'm going to just add in, especially because, got an r and a theta, and we're going to a place where we're going to have other types of coordinates. I'm going to point out that we're looking for x, y coordinates of the point of intersection. So I'll be solving for x equals this and y equals that. But I'll definitely be using a diagram. Okay, I've got a classic trig diagram. I'm going to draw a circle, and I'm not going to label it all that much. I'm going to draw a terminal ray at 11 pi over 6. So it's almost all the way to 2 pi. So that's my terminal ray. And then what I'm going to do is I'm going to make a reference triangle. Right, and this circle has radius 3. So I am going to go ahead and label that right there. That's a radius of 3. Now I'm going to go off to the side, and I'm going to draw another reference triangle, this one with hypotenuse 1. And this is going to be the unit circle equivalent. And I asked myself, what did I scale up the blue triangle by to get to the black and red triangle? That would be 3. Okay, so what's going to happen is, I multiply the respective sides by 3 to get the new triangle. So I know that this horizontal leg is going to be 3 root 3 over 2. And the vertical leg will be 2 times negative half is negative 1. Okay. Meaning the xy coordinates of this point are 3 root 3 divided by 2 and negative 1. Kind of just go through that same process for each of these. And I think I will have learned a little better. Draw a nice big circle and then draw the axes after the fact. I think that will end up being way better. Yeah, 5 pi over 3, almost all the way to 2 pi. Short of 2 pi by pi over 3. So it'll be kind of down there. And then I'll draw in the new triangle. Maybe I'll stick to red here. All right, and so I'm just trying to figure out what the coordinates of that intersection point are right here. And so we'll, use that. unit circle trigonometry to figure that out. Copy in the unit circle triangle. Okay, that's going to be a half, root 3 over 2 and 1 down in the fourth quadrant. Y is negative. Okay, and then this one had radius equal to 8, so I scaled it up by 8. 8 times a half is 4. Negative root 3 over 2 times 8 is a negative 4 square root of 3. Alright, so the x and y coordinates of the point are 4 and negative 4 square root of 3. Alright, next we got r equals 4, theta equals 7 pi over 6. Alright, so 7 pi over 6, that's a little beyond pi. It's a little bigger than 6 pi over 6. It's bigger by pi over 6, which is 30 degrees. So here, try in the rest of the triangle. Oh, that's not what was supposed to happen there. I should just let that snap to and then draw on the other side. Yeah, there we go. That's a little better. Okay, I'm going to draw the replica. Okay, as close as I can. Label it short leg, longer leg, hypotenuse. Okay, think about what's going to be negative. Both of them are going to be negative. He told me the radius of this circle is 4. So the hypotenuse of the red triangle is 4. I'm going to scale them up by a factor of 4. 4 times a negative half is a negative 2. 4 times negative root 3 over 2 is negative 2 square root of 3. And then the coordinates of the point are going to be x equals negative 2 square root of 3 and y equals negative 2. Right, for this one, 5 pi over 4, that's going to be another one down in the third quadrant. It's bigger than pi by pi over 4, so a 45-degree angle beyond there. Okay. 5 pi over 4. And so I'm going to draw the rest of my triangle. Okay, draw the replica, 45, 45, 90. Hypotenuse 1, root 2 over 2, and root 2 over 2. We're here in the third quadrant, both of these are going to be negative. And then I'm going to take, okay, oh, I forgot to label the hypotenuse of the red triangle, that's 11. So the red triangle is 11 times as large as the blue triangle. And if I scale those coordinates up by 11, I'd have a negative 11 root 2 divided by 2 and negative 11 root 2 divided by 2. Right, so those will be the coordinates of the point. Negative 11 square root of 2 divided by 2 and negative 11 square root of 2 divided by 2. Okay, r equals 1/2. Yeah, that's great. I'm going to draw the circle the exact same size I was going to draw it no matter what. Don't really care. The diagram is just what I'm drawing to help me get the right answer. Doesn't have to be all that accurate. 2 pi over 3. That's close to pi, just less than pi by pi over 3. So I go back by 60 degrees. Draw myself the rest of my reference triangle. And then I'll draw the replica in blue. And that's the short leg, which is a half. The long leg is root 3 over 2, and the hypotenuse is 1. Right, what's going to be negative? The half will be negative because that's over in the second quadrant. Okay, this triangle over here has a hypotenuse of a half because the circle has radius half. And I'm going to say, all right, well, I guess I scaled the blue triangle down by half to get the red triangle. So half of the negative half would be negative 1/4. And half of root 3 over 2 would be root 3 divided by 4. Okay, so the coordinates of the point are going to be negative 1/4 and positive root 3 divided by 4. Right, and then r equals 8, and theta is 5 pi over 6. Let's make another diagram. Right. 5 pi over 6, almost all the way to pi. Short by pi over 6, which is 30 degrees. So we go back up the circle, 30 degrees. Draw a reference triangle. And get the replica off to the side. It's a 30-degree reference angle. Hypotenuse is 1, short leg is a half, long leg is root 3 divided by 2. Okay, what's going to be negative? The root 3 over 2, because I'm in the second quadrant where x is negative and y is positive. And we got that. A new triangle has hypotenuse 8, because that's the radius of the circle. The negative root 3 over 2 is going to get multiplied by 8, negative 4 square root of 3. The 8 is going to get multiplied by a half and become a 4 there. And the coordinates of the point will be negative 4 square root of 3 and positive 4. All right, now the next set of questions all goes off the same diagram, like this one. So triangle AOB is inside of the circle such that angle AOB is a right angle and AB is perpendicular to the y-axis. Right, so basically what we're saying is that OA and OB are both radii, and it makes a 45, 45, 90 triangle, so that means that, you know, it's cutting the first two quadrants in half like it kind of looks like. Then COD is an equilateral triangle, which means all of those red marked angles are 60 degrees, and we're looking at, we're looking at pi over 3s, basically, is what we're saying. Equilateral with side lengths of 6. Okay, so I think I am going to label, that does mean that the radius of the circle is 6. Theta 1 is an angle in standard position passing through point B. Theta 2 is an angle in standard position passing through point C. All right. So I'm just going to point out, all right, standard position always starts on that axis and then rotates positively, positively is counterclockwise. Okay, try that again. All right, that's theta 1. And then theta 2 is going to be, and try to let that be still showing the blue going through C. So theta 2 goes all the way out there, whereas theta 1 just goes here. All right, that's what we're saying. Find the following. Coordinates of point A. All right. A is, to draw here, this diagram got a little crowded. I'm going to get rid of all of my writing here and just kind of zoom in on A, B, C, and D. Yeah. All right. So if I was to draw a triangle at A, here and there. All right, that's going to be a 45, 45, 90 triangle for a variety of reasons. I'm not even sure specifically which one is best. We know that AOB is a right angle and AB is perpendicular to the y-axis, which means that it's just sitting in there where all these are 45-degree angles. And just kind of gonna leave it at that. So this would be 1 root 2 over 2 and root 2 over 2, except I know that the radius of the circle is 6, so I got to scale this up by a factor of 6. So 6 root 2 over 2 and 6 root 2 over 2. The coordinates of A are going to be 3 root 2 and 3 root 2. Okay. For B, it's going to have the same y coordinate, because, I mean, you can just see that segment AB is perpendicular to the y-axis. So that means it's on a flat line, it's going to have the same y-coordinate. The x-coordinate is going to be the negative, I mean, kind of by the symmetry of the diagram, or you could just think about, putting that 45, 45, 90 triangle in the second quadrant. The exact same thing is going to happen. It's just going to return you a negative x value, so negative 3 times the square root of 2. All right, then for point C, let's see, I can get rid of that. All right, if it's the case, I guess that CD is perpendicular to the y-axis. That means that these are, forget what they're called, but they're kind of angles that have to be equal. That's one reason I see that that's got to be 60 degrees down that way above pi. But I'm sure there's other reasons why it's got to be. I think it might be alternate interior, but it's been so long since I've done geometry. I'm going to say, all right, so I'm going to go over here to point C. I'm going to draw the triangle right here. All right. I think I'm going to draw it as if it was just, as if it was on the unit circle, but we know that the radius is going to be 6, so that's going to scale up by 6. 1, the short leg is a half, and the long leg is root 3 over 2. Okay, make them negative. Now we're going to multiply everything by 6. And for point C, the x-coordinate would be 6 times negative a half, and 6 times negative root 3 over 2. All right, for point D, you can kind of see it's just going to reflect across the y-axis, so the x is going to become positive instead of negative, and the y-coordinate will stay the same because again it's on that horizontal line. So negative 3 square root of 3. All right, so we found the coordinates of the points. All right, the measure of each of the angles in radians. All right, COE. So we're talking about this angle here. Okay, we determined that was a 60-degree angle above pi, and 60 degrees is pi over 3, so I'm going to call that pi divided by 3. All right, BOE. BOE. All right, so B to O to E, that's going to be 45 degrees because we're using 45, 45, 90s there. So 45 degrees, that's pi over 4. DOE. And so D to O to E. And I'm just going positively here. I mean, I understand that if it starts at D and it's then going to O and E, that might feel like negative. But what I'll say is that these aren't standard position angles, so kind of like, we're just looking for like the measure of the angle. Okay, so this is an obtuse angle. It's got to be bigger than pi over 2. Okay, it's 60 degrees plus another 60 degrees. So that would be, if 60 degrees is 1 pi over 3, we can kind of see it happening. Here's, that angle, and then that's the same angle. So that'd be 2 pi over 3. Right. AOE. I'll switch over to blue here. A to O to E. All right, we've got the 90 degrees and another 45. So that's like 3 pi over 4 right there. 90 plus 45 is like pi over 2 plus pi over 4. That would be 3 pi over 4. Then C to O to B. Ooh, I like this one. This one's interesting. So C to O to B. All right, so COE, that was 60 degrees we determined earlier. And EOB is 45 degrees. And, like I know how to add 60 to 45. But I think I'm going to write it out like this so that we can convert this to radians, because I don't know about you, but I don't know how to convert 105 to radians. So I'm going to say 60 is a pi over 3 angle, and a 45 is a pi over 4 angle. And so I'm going to need to convert these to twelfths. So 4 pi over 12 plus 3 pi over 12, and that'll give me 7 pi divided by 12. Which is not really an amount of radians we know a whole lot about, except for we can make it out of a 45 degree and a 60 degree angle. All right, now it's bringing up theta 1 and theta 2. So I'm just going to remind you that theta 1 goes through point B and theta 2 goes through point C. So what I'm going to do, I'm going to just redraw the diagram, I think. So, yeah, you can see point B is up there 45 degrees shy of pi. So I'm going to just kind of draw the diagram. All right. Okay, and then I feel like I can do a little better than that. All right, let's just one more crack at it. Yeah, I think that'll be good enough. Okay, so sine of theta 1 is, if I draw my reference triangle, that's just opposite over hypotenuse. So 1 root 2 over 2 and root 2 over 2. All right, and so sine of theta 1 opposite over hypotenuse, root 2 over 2. Okay, and then 6 times the sine of theta 1, that's going to be, well, 6 times root 2 over 2 is 3 square root of 2. Don't really, with this one like this, don't overthink it. If you've already got sine of theta 1 or the ability to find sine of theta 1, just use your reference triangle, right? The one that has hypotenuse 1, because that helps you find sine, cosine, tangent of any angle, as long as it's on the unit circle, or one of our, special right triangle angles. And then multiplying by something, just deal with that after the fact. Okay. And so for theta 2, that went through point C, which was down pi over 3 beyond pi, so like 4 pi over 3. So I'll draw in the diagram. All right, so there we are, 60 degrees beyond pi, and we're going to say we've got our reference triangle drawn. The hypotenuse is 1, the short leg is a half, and the long leg is root 3 divided by 2. Yeah, I'm realizing that I forgot to make this negative, and then it didn't even impact the answer. But I felt bad for not labeling the things negative that are supposed to be negative, because that was the new thing in the lesson. Okay, so over here in the third quadrant, both of these quantities will be negative because x and y are both negative in the third quadrant. And so if I'm looking for sine of theta 2, opposite over hypotenuse, negative root 3 over 2. And then 6 times the sine of theta 2, well, I'd take that negative root 3 over 2 and multiply it by 6, and I'd get negative 3 square root of 3. Now, terminal rays extending from radian measurements of pi over 6 and 11 pi over 6 intersect with the circle of radius 12 at 2 different points. What's the vertical distance between these 2 points? All right, I know what we're getting at here. And all right, I'm going to do these 2 first. I'm going to zoom in this way, yeah, because that's the information that we really need. All right, so I'm going to start with pi over 6, that's a 30-degree angle up here. Okay, and then 11 pi over 6, that would be back by 30 degrees that way, and that's a little bit off from the angle I'd drawn on the other one. I'm trying to make it as close as possible. All right, great. So really what we're going to need is, we're going to need the coordinates here, and I guess the coordinates of these 2 points. And I mean, there's a bunch of ways to do it. You could even say it's going to be 12 because it's going to become an equilateral triangle. If you see that coming, good for you. But I'm thinking about what the answer choices of this equivalent multiple choice question look like, and I think that you might pay attention to the way I'm going to solve this. All right, so I'm going to say they intersect at 2 different points. I'm going to call them A and B. I'm going to label the coordinates of point A. So for A, right, I could find the x-coordinate by taking the radius, which is 12, and multiplying by the sine of pi over 6. Okay. So what I'm going to say is, yeah, maybe I'll draw out the triangle over here. Okay, so this is pi over 6. Okay. Suppose I'm looking for the x-coordinate. Okay, sine of pi over 6 equals, don't want sine, I want cosine, pardon me. So cosine of pi over 6 is going to equal adjacent over hypotenuse, meaning x is going to equal 12 times the cosine of pi over 6. Right, so A is going to equal, A is going to have coordinates x equals 12 cosine of pi over 6. And then if I was thinking about, the y coordinate, I could do the same thing with sine, right? And just kind of replace x with y. So sine of pi over 6 equals y over 12. And as a result, I could say y is equal to 12 times the sine of pi over 6. All right, and then point B is going to have coordinates given by 12 times the cosine of 11 pi over 6 and 12 times the sine of 11 pi divided by 6. Okay, and then if I was to get rid of that little marking there and use blue here, this is going to be the distance between the 2 points. And this homework problem is really nice. It says vertical distance. But I know of a problem that doesn't tell you whether it's vertical or horizontal, and you just got to know based on kind of the locations of these theta values. That you just would have to know that pi over 6 and 11 pi over 6 were right above and below each other, and so we're looking for a vertical distance. A vertical distance, on an xy plane is always going to be a difference of 2 y coordinates. So this would be the y coordinate of A minus the y coordinate of B, top minus bottom. So this vertical distance is going to equal 12 sine of pi over 6 minus 12 sine of 11 pi over 6. Okay. I'll leave it to you to do the trig and figure out that this is going to actually equal 12. Okay, you can do it with the triangles. Okay, but that's what's really important is what is to the left of the blue equals. All right, so the next one we've got 3 pi over 4, which is over there, and 5 pi over 4, which is over here. Both kind of at 45-degree reference angles. That looks pretty close to like the 2 blue lines are intersecting at a right angle, so I'll live with it. You can definitely do, you can do other types of trigonometry to find the actual distance. I'll give you the distance if you want to check that, but again, I'm gonna do this in terms of the sines and cosines. and point out, okay, so if I call these points P and Q, point P is going to have coordinates radius 7 cosine of 3 pi over 4, and 7 sine of 3 pi over 4. And Q will have coordinates 7 cosine of 5 pi over 4, and 7 sine of 5 pi over 4. All right, so if I want this vertical distance in here, right there, that's something I would obtain by getting the difference of two y coordinates. It would be y of the top minus y of the bottom. Okay, so top minus bottom. That distance is going to be equal to the y coordinate of p, 7 times the sine of 3 pi over 4, minus the y coordinate of q, which is 7 times the cosine of 5 pi over 4. No, I just was not copying. I'm talking about this coordinate right there. 7 sine of 5 pi over 4. All right, and I will tell you that that's going to equal 7 times the square root of 2. Right, now we got 2 more of these. Okay, so I'm going to say, all right, pi over 3 and 2 pi over 3. If I was to draw, I need to draw the axes. Pi over 3 and 2 pi over 3, those are going to be up here at 60 degrees, and also up here at 60 degrees. And so, if you're paying attention to that stuff on like the previous type of example, the one where there was the two 60-degree angles, it ends up making an equilateral triangle. So the answer is 4. The horizontal distance is going to be 4, but that's kind of not what I'm getting you ready for here. All right, so it's going to label the points. So I'll say this one's going to be point A and that one's going to be point B. Okay, the coordinates of A are going to be x equals, okay, A corresponds to theta equals 2 pi over 3. So x equals, the radius is 4 times the cosine of the angle. And then the y coordinate would be 4 times the sine of pi over 3. But these were 2 pi over 3. I said it and I made the same mistake. Okay, because A went farther, A is the one that corresponds to 2 pi over 3. B is going to be the one that corresponds to 1 pi over 3. So for cosine of 1 pi divided by 3 and for sine of 1 pi divided by 3. All right, now if I want this horizontal distance here, I'll be taking the difference of two x coordinates. Do right minus left, xb minus xa. Because if I did left minus right, I'd end up with a negative number. And so this distance that you can kind of see, it says horizontal, but I kind of want you to get beyond, depending on that, because you won't always be able to see that. That knowing that you're going to take a difference of two x coordinates. So it's going to be from this one to that one. So this distance is 4 cosine of pi over 3 minus 4 cosine of 2 pi over 3. And then I'll also just tell you that's going to equal 4. I can just tell by geometry. All right, the last of these is the 5 pi over 4 and the 7 pi over 4. Best I can. That looks decent. And, all right, circle of radius 11. So, oh man, yeah, I can see I tried, but you're supposed to definitely have the same y coordinate, but they definitely don't. It's okay. Maybe I'll call this one P and that one Q. And I'll say, all right, coordinates of p. P corresponds to 5 pi over 4. So it'll be 11 cosine of 5 pi over 4 and 11 times the sine of 5 pi over 4. And point Q will go 11 cosine, that's 7 pi over 4 down in the fourth quadrant, and 11 sine of 7 pi over 4. All right, and if we're wanting this horizontal distance here, which is kind of horizontal, you can see it's definitely not intersecting at a right angle, but yeah, I tried. It's going to be x coordinate of Q minus the x coordinate of P. Right minus left. All right, so I'm going to go back there. I'm going to say, all right, this equals 11 cosine of 7 pi divided by 4 minus 11 cosine of 5 pi divided by 4. And that's going to equal 11 times the square root of 2. All right, now we've got kind of the backwards question from one we did a few ago. Wow, this homework just keeps going. Oh boy. All right. Well, all good. This is exactly what you need to do, though. This is what you need to do to get that good mastery of trigonometry. Okay. So 5 root 3 and negative 5. All right. I think what you need to know is that root 3 is bigger than 1. So 5 root 3 is going to be like a larger number than 5. So if I was to, hold on, I don't really like that. Maybe if I draw my axes like that, because I'm going to be down in the fourth quadrant. All right, yeah, 5 root 3. Maybe I'll just decide that's going to be right here. What I'm saying is negative 5 will be not that far down. Okay, significantly less than 5 square root 3. We know that if we've got a square root of 3, it's probably meaning we're at a 30, like we're working with a 30, 60, 90 triangle is what I'm saying. And then if we just kind of draw the diagram, then can't go wrong, maybe. We're lucky. All right, so I got myself a triangle here, and right, this is okay. 5 root 3 is the. I'm saying. Yes, that's what I'm saying. That the legs of the triangle, the legs of this triangle I'm working with are 5 root 3 and negative 5. So I got to figure out what the hypotenuse is because that will be the radius of the circle, right? Because somewhere out there, somehow, I might I'll get lucky and draw a good one. You know, there's a circle out there with that radius, and I just need to find that radius by finding the hypotenuse of the triangle. And what I think I'm going to do, there's no shame in using the Pythagorean theorem. I'm going to say 5 root 3 squared plus negative 5 squared equals that radius squared. And I'm going to say, all right, if I square 5 root 3, I'll have 25 times 3. So I'll have 2 powers of 5 and 2 powers of square root 3. Plus 25 equals r squared. Okay, 75 and 25 is 100, equaling r squared. We want the radius of our circle to be a positive number, so we're going to say r equals 10. Okay. Then, as far as theta goes, look, we can see that this is a, 1, 2 square root of 3 is a 30, 60, 90 triangle, and that's the short leg, so that must be a 30-degree angle. I'm 30 degrees short of 2 pi. Okay. You could call this negative pi over 6 if you wanted, but that's kind of not really where we're at right now. But theta equals negative pi over 6 would be a perfectly fine answer. I would say that's 2 pi minus a pi over 6, which is 12 pi over 6 minus 1 pi over 6 is 11 pi divided by 6. And then the other one of these is, oh no, there's 2 others of these. Okay, so I'm going to need third quadrant. Okay, negative 9 root 3 is going to be a bigger number than negative 9. So I'll just make negative 9 over here, negative 9 root 3 all the way down here. Draw myself a special right triangle. That'll do. Okay, yeah, man, you can get the point. So negative 9 would be this leg, negative 9 root 3 is going to be that leg, and we'll have r down here. Okay, this is pretty clearly a 60-degree angle. If this is a 30, 60, 90 triangle, that's not the 30 degrees. So it's going to be pi plus a 60-degree angle is pi over 3. That's 4 pi divided by 3. Then to find r, I'm going to use the Pythagorean theorem. Negative 9 squared plus negative 9 square root 3 squared equals r squared. That's 81 plus 81 times 3 equals r squared. Oh, okay, so in case you don't, in case you're kind of like reaching the bounds of your arithmetic, what we can do is factor out an 81 from this and have a 1 plus 3. I'm going to do a little bit of more advanced arithmetic here. So if 81 times 4 equals r squared, and r is a positive number, then r is going to equal the square root of 81 times 4, which is equal to the square root of 81 times the square root of 4, which is going to equal 18. Okay, so you didn't really need a calculator for that. Now, if you know the pattern, if it's like 1, 2, square root of 3, then the hypotenuse is going to be twice the length of the short leg. Well, then you can just know that easily. But if you need to use the Pythagorean theorem and it starts to run out of control and you know it's supposed to get to be an integer, well, then you can just kind of use a technique like that. All right, negative 1 and square root of 3, what are theta and r? All right, so negative 1 is not going to be as far as positive square root of 3. So maybe I'll put negative 1 there and positive square root of 3 over here. Should have committed to the point before I labeled the spot on the axes, but I'd say that's about as close as we're going to get. I'm going to go back down. Hope for the best. Yeah, I'll just get rid of that one. Yeah, now it looks great. And we'll say, all right, that's a negative 1. This is a positive square root of 3. Okay, so I think that the radius is going to be 2, right? Because it's twice the short leg. But I can go ahead and determine that for sure. This is a 30, 60, 90 because it's got a square root of 3 in it. So, and I can tell that this is the 60-degree angle right here. So I'm going to say that this is pi back pi over 3. Okay, so subtracting pi over 3, that would leave me with 2 pi over 3. 1 minus a third, that's 2/3. Then to find r, the radius of the circle, or the hypotenuse of the triangle, I'm going to use the Pythagorean theorem. Negative 1 squared plus square root of 3 squared equals r squared. So 1 plus 3 equals r squared. That feels like r equals 2 to me. Equals 2, theta equals 2 pi divided by 3. All right, now here we are on the last page. Point A is located on a circle of radius 5 with coordinates negative 3 and 4. All right. B is located at the coordinates 2 and negative square root of 21. They're not directly across the circle from each other. Because that would just be point, I think 4, negative 3 would be the exact opposite point from the circle. Or maybe 3, negative 4. No, it'd be 3, negative 4. And I don't know, one of those two. But that's not the same as 2 and negative root 21. Okay, cosine of theta 1. Okay, I'm going to draw a triangle that represents theta 1, and I'm going to draw it in black because that's kind of the color that we used on the diagram. Okay, so the reference angle for theta 1 is going to be right there. And I'm going to say the coordinates of A are negative 3 and 4, and the radius of the circle is 5, so the hypotenuse of that triangle is 5. And cosine of theta 1, we're just going to do SOHCAHTOA. We drew our triangle. We're going to work from that. So negative 3/5. Oh, no, theta 1s are all along the left. Tangent of theta 1 is opposite over adjacent. 4 over negative 3 is negative 4/3. And cosecant of theta 1, okay, well, sine of theta 1, I'm going to start with that. That's opposite over hypotenuse. 4 over 5. So cosecant is 5 over 4. Now I'll draw a triangle for theta 2. And it looks like it's kind of tall. So I'll just kind of draw it with the same kind of proportions. That'll be my reference angle for theta 2. I don't know what the radian measure is or the degree measure. I don't really care. It doesn't matter because I've got all the side lengths. So x is 2. Y is the negative square root of 21. And that is going to make, yeah, because 21 plus 2 squared is 25. And that, yeah, it's going to give it a hypotenuse of 5. So that makes sense. Cotangent of theta 2. Well, I need to first find tangent of theta 2. Would be opposite over adjacent, negative root 21 over 2. Okay, so if I flip that, I'd have negative 2 over the square root of 21. 21 is not going to be reducible because the only factors I can think of it are 7 and 3, and neither of those are a perfect square. So I'd multiply by root 21 over root 21, and I'd get negative 2 square root of 21 all divided by 21. All right, sine of theta 2 is opposite over hypotenuse, negative square root of 21 all divided by 5. And then secant of theta 2, I would need cosine of theta 2. First, cosine of theta 2 is adjacent over hypotenuse, 2 over 5. So that means secant is going to be 5 over 2. All right, so here we've got another diagram. Circle with radius 20 and 8 labeled points. And then the gray dotted lines sit at 45-degree angles on the x-axis. So asking which segment could have length 20 cosine pi over 3 minus 20 cosine 2 pi over 3. Okay, so if we're thinking about the difference in two cosines, the cosines represent x coordinates on the circle. Okay, hopefully you put that together now. We're seeing there that they always correspond to that horizontal leg when we draw the reference triangle that same way that we always do. So what we're saying here is that cosine of pi over 3 and cosine of 2 pi over 3 go to the ones that could possibly represent pi over 3 and 2 pi over 3. That's B and C. Okay, and the cosines, the difference in them, would represent the horizontal distance there. So I'm going to say B to C, segment BC. Okay. Another one that has like kind of horizontal stuff to it is 5 pi over 6 and pi over 6. But wait a second, that's kind of backwards. That's going to give me a negative number. Let's say, because I did left minus right. And I fixed the first one. But I'm going to say that's a negative number, but it could possibly represent the segment AD. I think the other ones are fine, though. Yeah, okay, so for the other one, sine of 2 pi over 3 minus the sine of 4 pi over 3, that's going to be a difference in y coordinates because it's sine minus sine. But the one that looks like it could represent 4 pi over 3 is pi over 3 beyond pi, that's f. So I'd be talking about this vertical distance here, and that'll be CF. And then sine pi over 6 minus sine 11 pi over 6, that would be the difference in y coordinates between these 2 points. Okay, and they're scaled up by 20 so that they'll actually be, long enough to, what am I saying? If it was just sine of pi over 6 minus sine of 11 pi over 6, that would be us working on a circle of radius 1. So 20 times as big as we're working on a circle of radius 20. That's what I'm trying to say. So AH is the segment there. And then write a segment that could have length 40. Okay, well, if the radius is 20, 40 represents the diameter. So really any of them that are just like directly across from each other would work. But maybe I'll just say, you know, CG looks like two that are directly across from one another, and that's a line. I'm just talking about probably wanting the segment. So that was pretty bad. I'm going to try one more time for that. Yeah, that's great. Goes through the origin. Talking about segment CG. Yes, that is it. All right, an hour and 5 minutes in. That was a long homework, right? But I think that was exactly what you needed. If you worked all those problems, then that was a really good set of practice, and you're well on your way to mastering the trigonometry skills we need you to master in this class. So that's all for this video. Thanks for watching.